So this is question 5A1 from 2024 Higher Level Maths Leaving Cert Deferred Paper 2. Assume that the margin of error for a population proportion is 1 over root n, where n is the sample size. A survey is carried out on a random sample of 1600 people. Find the margin of error for a population proportion based on this sample. Give your answer as a percentage. Okay, so we have 1 over square root n. So in our case it's going to be 1 over square root 1600. That is 1 over 40. So that's our margin of error, but we've got to do it as a percentage. So we take our 1 over 40, we multiply by 100, and that'll give us 2.5%. So that's it for this part. Very straightforward question. So let's have a look at part 2. What sample size would be needed to give a margin error of exactly 1%? Well, we work out our margin of error as a percentage by taking 1 over the square root of n and multiplying by 100. We need to let this equal to 1%. So very straightforward again, just multiply across by square root n. You get 100 is equal to square root n. Square both sides, you get 10,000 is equal to n. That's it for part 2. So let's look at B part 1. A, B, C, D and E and F are 6 events. A and B are independent. The probability of A is equal to 0.2. Probability of B is 0.3. Find the value of the probability of A intersection B. So they use the word independent here, so immediately you should kind of write down the formula for independent events. The probability of A intersection B is equal to the probability of A times the probability of B. So we need to find this here. We're given the probability of A, we're told it's 0.2. We're given the probability of B, it's 0.3. Multiply those two together, you get 0.06. The only thing you needed to remember there was the formula for independent events. This is part 2. The probability of C is equal to 0.4. The probability of D is 0.5. The probability of C intersection D is 0.08. Find the value of the probability of C union D. So what we need in this particular question is the formula for non-mutually exclusive events. So the probability of C union D is equal to the probability of C plus the probability of D minus the probability of C intersection D. So let's see, we have the probability of C, it's 0.4. We have the probability of D, it's 0.5. And the probability of C intersection D is 0.08. So when you add up all of these, you get 0.82. So the probability of C union D is 0.82. So this is part 3. The probability of E is 0.6. The probability of F is x plus 0.4. The probability of E intersection F is x, where x is real and is a constant. Find the value of x for which the probability of E given F is 1/4. So this is a conditional probability question, so you need to write the formula for that down. So it is E given F is equal to the probability of E intersection F divided by the probability of F. So we have the probability of E given F is 1/4, so that goes on the left hand side. The probability of E intersection F is x. The probability of F is x plus 0.4. So it's just a case of solving this particular equation. So we have a fraction equal to a fraction, so we can cross multiply. So we have 1 times x plus 0.4, that's x plus 0.4. 4 times x is 4x. Let's bring that x over here, so we have 3x on the right hand side is equal to 0.4. And then divide by 3, you get x is equal to 0.4 divided by 3, which is 2 over 15. And that is all we have to do, just find the value of x. So that was again reasonably straightforward. So in this question you needed to know the formula for independent events, for mutually exclusive or non-mutually exclusive events, and for conditional probability.